A mass melt off the icy continent Antarctica is one of the worst-case scenarios of climate change. If that happens, scientists say it will be far into the future. But in a possible taste of things to come, Australian scientists have used a recent colossal ice crash in Antarctica to see how the Earth's oceans are changing. It's already known oceans are becoming less salty, more acidic and warmer. And Antarctic waters hold the key to understanding what's going on. From the Antarctic icebreaker Aurora Australis, Karen Barlow reports.
It is the bottom of the world. Inhospitable, bone-snappingly cold, yet Antarctica is full of life.
I never get tired of coming here. It's a fantastic part of the world.
Ice rolls off the continent here from the Mertz Glacier in the gigatons every year. The glacier's ice tongue, jutting out from the continent, was rammed by this equally colossal iceberg last year, and most of the tongue snapped off. While not the result of climate change, this calving event is under close scrutiny as a possible pointer to the future.
What it does allow us to do is to see how the ocean responds to an event like that, because as the climate does warm, we do expect the Antarctic ice sheet to lose more mass, to melt more, and this is a way for us to get an early indicator of what those sorts of changes might bring.
The Mertz Glacier region is important for the creation of global ocean currents which help drive the planet's climate. A phenomenon known as a polynya is involved in the circulation of the oceans. Ice is pushed off the Antarctic coast along with dense, cold and very salty water, which sinks to the Southern Ocean floor, the beginning of a journey around the planet.
So we've seen warming in the Southern Ocean, pretty much from the surface right down to 1 or 2 kilometres below the surface. And some of the dense water that forms around Antarctica is freshening. And what that means is that the ocean circulation patterns that influence climate are also changing.
The first results from the Mertz Glacier experiment show it's a different region this year. The seafloor under the glacier has been exposed for the first time because of the tongue breaking off. Scientists used an underwater camera to capture these images. This is polar coral.
Hey, it's a nice big sea star. That's at least 50 centimetres across, which is huge. You know, the ship's going where no ship has gone before, and we're getting photos of the seafloor that no one knew what was down there. There was probably a lot of speculation about what could have lived there, but this is the first evidence we've got of what was actually underneath the Mertz Glacier tongue.
Scientists have also been testing the waters with an array of samplers and sensors. Conductivity, temperature and depth, or CTD sensors, were deployed and recovered at 150 ocean spots along the voyage from Hobart to the Mertz Glacier.
Just on the edge of a deep depression where all the dense bottom water that forms during the winter piles up.
Sometimes the water was tested at depths of almost 5,000 metres.
Okay, the temperature's minus 0.6.
It's a round-the-clock team effort, recording levels of nutrients, salinity, carbon and oxygen.
I do notice once we've hit further south and past the polar front, there's some really high oxygen water, very fresher, colder water at the surface, so it's pretty high in oxygen.
Sea ice built up over many years behind the glacier tongue is now free. It's been melting and freshening the water, creating perfect conditions for ocean plants called phytoplankton.
A surprise to us on this trip was just how much biological activity there is in the phytoplankton, at least. So we're in the midst of a huge phytoplankton bloom. That was a repercussion of the calving of the tongue that we hadn't anticipated, so that's been a surprise to us.
There's a hell of a lot more carbon being fixed by phytoplankton and taken out of the dissolved carbon being taken out of the water. So it's about in this area we've been looking at, about 1 million tonne of carbon has gone into phytoplankton, and that's very unusual. We don't normally see that in this region.
The carbon dioxide absorbed by the phytoplankton bloom in this small area around Antarctica equals 1% of Australia's annual CO2 emissions. What the changes triggered by the break-off of the glacier tongue mean to the Mertz region and whether they're permanent are unknown. Phytoplankton's ability to absorb carbon slows the rate of climate change, but they're sensitive to ocean warming and can only take so much carbon.
It's a sink at the moment. In wintertime, it might be a small source because of the mixing, and there's also a lot of ice cover though at that time, so not much gets out to the atmosphere.
The Southern Ocean is a great contributor to Australia's and the planet's climate. Any changes would ultimately show up in our atmosphere.
The changes like those we measure here in Antarctica, and the changes we see in the atmosphere, and the changes we see on the land surface and in low latitudes and high latitudes, that whole picture is fitting the pattern that we expect to see as a result of greenhouse gas-driven climate change.
So if the usual cold, dense, salty water is not being formed, then there may be flow-on effects.
As the waters get fresh, if they get too fresh, they won't be able to sink anymore. And that'll change one of the drivers of the global circulation patterns that influence the climate system.
People think of the ocean as this, it's used as a disposal for a lot of countries, and they're not very... I think in the old days that was fine, there was a small population. We're a big population on Earth now, and we can do a lot of damage.
The exhaustive scientific work on board the Aurora Australis, the latest expedition in a series that started 20 years ago, is discovering how and why the Southern Ocean is changing. Karen Barlow, Lateline.